Around the world, countless people wait, not for a bus or a package, but for a second chance at life, an organ transplant. For them, every day is a test of patience and hope, as they cling to the possibility of a future that depends on a phone call that could come at any moment, or never at all. The organ transplant waiting list is a stark reminder of our medical limits. Every name is a person whose body is failing, hoping for a miracle that depends on another's loss. Behind each entry is a story, a family holding its breath, a life paused in uncertainty, and dreams put on hold. The numbers are brutal. Far more people need organs than there are available donors. This creates a silent crisis, a lottery with life and death as the stakes. Every year, thousands never get the call, their hopes fading as time runs out. For every transplant success, many more wait, their health slipping away. Families watch helplessly, caught between hope and despair, as they witness their loved ones grow weaker with each passing day. Medicine can manage symptoms, but for a cure, we rely on chance. Doctors do all they can, but ultimately, the solution is out of their hands, dictated by the unpredictable generosity of strangers. But what if we could change that? What if organs could be built to order, crafted for each patient? Imagine a world where no one has to wait, and no life is lost to shortages. This is no longer science fiction. Researchers are learning to read the language of our cells, unlocking the code that tells a cell to become a heart, a liver, or a lung. Step by step, they are turning the impossible into reality, using cutting-edge technology to grow organs from a patient's own cells. The end of the agonizing wait is finally coming into view. For the first time, there is real hope that the days of endless waiting and heartbreaking loss could soon be behind us. The future of organ transplantation is being rewritten, not by luck, but by design. Scientists and doctors are working together to create solutions that were once unimaginable, bringing new life to those who need it most. The question is no longer if, but when. The countdown to a new era in medicine has already begun, and every day brings us closer to a world where no one has to wait for hope. And that future is closer than you think. The race against time is being won, one breakthrough at a time. The revolution begins with stem cells, the body's master builders. These undifferentiated cells can become any cell type, heart, brain, skin, you name it. Scientists have learned to reprogram adult cells into induced pluripotent stem cells, or iPSCs, creating custom building blocks from a patient's own tissue. This breakthrough means organs can be grown with a patient's DNA, eliminating rejection. The challenge: giving stem cells the right instructions, like handing a construction crew a blueprint. Researchers are now designing those blueprints, guiding stem cells to assemble into complex tissues and eventually entire organs. The era of personalized lab-grown organs is on the horizon. The master builders are ready. Now, it's all about the plan. Building an organ isn't just about growing the right cells, it's about arranging them in a precise three-dimensional structure where every cell knows its place and purpose. This process is like constructing a complex building, where each brick must be set in exactly the right spot for the whole to function. Scientists discovered organizer cells, the foreman of development, release signals that guide stem cells to form functional organs. These organizer cells act as conductors, orchestrating the symphony of cellular development, ensuring that each type of cell grows where it's needed most. In 2024, researchers engineered these organizer cells to direct stem cells to form a beating, miniature heart in the lab. This tiny heart pulsed with life, demonstrating that we could not only grow tissue, but also shape it into a living, working organ. This was a breakthrough. For the first time, we could write the instructions for organ formation, almost like programming a biological computer. Scientists could now influence the fate of cells with unprecedented precision. The goal is to create a library of blueprints for every major organ: heart, lung, liver, and more. Each blueprint would be a detailed map showing exactly how to assemble living cells into a functioning organ, tailored to each patient's needs. Imagine, a patient's skin cell becomes a stem cell, then a new perfectly matched heart, grown in the lab. No more waiting lists, no more rejection. The dream is to make organ shortages a thing of the past, and to give hope to millions in need of transplants. The architects of cellular life are building a future where organs are made to order, custom designed for each individual, using the patient's own cells to ensure perfect compatibility. The blueprint is the key, a master plan that unlocks the secrets of organ creation and regeneration. And we're learning to draw it, one cell at a time, shaping the future of medicine with every new discovery. While full-sized organs are still in development, scientists have already mastered growing organoids, miniature, simplified versions of organs, in the lab. These tiny structures, like mini-hearts and mini-brains, mimic real organ function and architecture. Organoids let researchers study diseases, test drugs, and even model genetic conditions without risking human lives. Mini-brains help us understand Alzheimer's and Parkinson's. Mini-hearts reveal how new drugs affect cardiac tissue. Personalized organoids allow doctors to test treatments on a patient's own cells, ushering in truly individualized medicine. These living models accelerate research and bring cures closer. Organoids are more than a stepping stone. They're transforming medicine right now. The future of research is alive and growing in a dish, and it's changing lives already. Enter 3D bioprinting, a revolutionary technology that prints living tissues, layer by layer, using bioink made of human cells. This process is transforming the way we think about organ transplants and regenerative medicine, offering hope to millions of patients worldwide who are waiting for life-saving organs. It all begins with a detailed digital scan of the patient's organ. Advanced software then converts this scan into precise print instructions. Next, a bioprinter deposits layers of living cells and supportive gel in exact patterns, gradually building up complex functional structures from the ground up, structures that mimic the intricate architecture of real organs. Recent breakthroughs include the ability to print robust blood vessel networks, which are essential for nourishing tissues, and even lung scaffolds containing millions of tiny air sacs. These advances are bringing us closer to printing fully functional transplantable organs. What's truly remarkable is that these organs can be printed using a patient's own cells, ensuring a perfect match for both fit and function. This customization dramatically reduces the risk of organ rejection and eliminates the need for lifelong immunosuppressant drugs. Imagine a future where a digital file for a kidney can be sent instantly to any hospital in the world, and a new organ is printed on demand, ready for transplantation when the patient needs it most. 3D bioprinting merges biology, engineering, and information technology, redefining what's possible in medicine. It's a true collaboration between scientists, doctors, and engineers, all working together to push the boundaries of what we can achieve. The vision is bold. No more waiting lists, no more organ rejection, just precision healing tailored to each individual. Families can look forward to a future where hope replaces uncertainty. The future of organ replacement is being built, one layer at a time, and it's almost here, promising a new era in healthcare where science and compassion come together to save lives. While we learn to build organs, another solution is emerging xenotransplantation, using organs from other species like pigs. Gene editing tools like CRISPR allow scientists to humanize pig organs, making them compatible with our immune systems. In 2024, a genetically engineered pig kidney was successfully transplanted into a human, ending years of dialysis. Companies are now raising herds of gene-edited pigs to provide a steady supply of organs. Xenotransplantation offers a near-term answer to the organ shortage, bridging the gap while lab-grown and printed organs mature. What once seemed impossible is now saving lives. The bridge between species is real, and it's changing the future of transplantation. The age of organ scarcity is ending. Regenerative medicine is already changing lives. In 2014, scientists grew lab-made vaginas for girls born without them, using their own cells. Years later, the organs functioned perfectly. 3D printed ears, seeded with a patient's cells, now replace painful surgeries for children with underdeveloped ears. Lab-grown bladders, skin and blood vessels have been successfully implanted, restoring health and hope. Each success builds confidence and knowledge, paving the way for more complex organs. These patients are pioneers, their stories proof that building with biology works. The revolution is real, and it's already begun. Every new success brings us closer to a world without waiting lists. The future is being written, one patient at a time. Imagine a future where organ transplant waiting list is a term from history books. Organ failure becomes a treatable condition, not a death sentence. Need a new heart? Doctors grow one from your own cells or print it to your exact specifications. For urgent cases, a humanized pig organ is ready on demand. The organ shortage is solved forever. Medicine shifts from managing decline to regenerating health. Diseases like diabetes and cirrhosis are cured with lab-grown tissues. Lifespans extend, not by prolonging suffering, but by renewing the body. This isn't fantasy, it's the logical outcome of today's breakthroughs. The era of waiting is ending. The age of regeneration is here. Humanity now holds the power to build life, not just observe it. We're moving from passive subjects of biology to active creators, authors of a new chapter in evolution. With this power comes responsibility, to use it wisely, ethically, and compassionately. The goal is to heal, to alleviate suffering, and to ensure access for all, not just the privileged. Scientists are explorers, mapping the inner universe of the cell, driven by the same curiosity that sent us to the stars. This quest is noble, urgent, and within our grasp. We are the universe made conscious, learning to heal ourselves. Ending organ failure is now possible. It's our cosmic duty to see this journey through, for everyone. The future of life is in our hands.